Okay, here we go. Welcome to our four-function note time. So four-function, what does that mean? We've been looking at linears, right? We've been looking at lines and linear equations for the majority of our time together in algebra so far. And we've noticed some things. We've noticed that we've got some straight lines. When we graph them, they always are straight, they always are continuous, and their equations look the same. So as far as four functions, we're already really good with one of them. There are three other functions that we'll work with in algebra and in Algebra 2 trig and in pre-calculus and calculus and beyond. And so we're going to get a nice introduction to them as well today. Just an intro though. So what are we talking about when we are talking about these four functions and an introduction? Well, we're talking about what do they look like visually. For linears, we just talked about a line, linear equation. When you graph it, will always be a straight line. Okay, that one wasn't straight, but you get my point. And we'll also look a certain way as far as its equation. We'll just see a y and an x. There are, what? No exponents. We'll never see an exponent. No expo, so that's exponents. We'll never see an exponent when we're talking about linear. We can see that sometimes x and y are on the same side, like this one, which is a standard form, right? That's still linear. And this first one was in slope-intercept form, right? We've worked with that form a lot. Sometimes a linear equation just has a y, right? If we graphed y equals 5, that would be a horizontal line. And sometimes y is on one side and x is on the other, but it looks like it's in a different type of form. As long as there are no exponentials and there are no x's or y's, well, really, there are no x's. How about this? There's no x in the denominator. We're good to go. As we look at the other function, we'll come back to this and talk about what else does it mean when an equation is linear. But right now, this is a good representation of how different linear equations can look. So we're going to briefly look at everything quadratic. And so we look at their graphs, and we see that it looks like a quadratic is either a U or an upside down U, right? These graphs are actually called parabolas. We don't need to know that right now, but so we're looking at a quadratic, and I have a goofy way to remember that quadratics look like U's. You know why quads look like U? Because you have quads. Okay, you can't see me pointing to my quads, but right, our quadriceps, those are the muscles in the front of our legs. So that's kind of how you can remember. You may be like going, oh, Miss Overby, that's so corny. But it's the way a lot of people remember. Quads look like you because you have quads. Okay, so that's one way you can remember how quadratics look like when you graph them. Let's look at the equations, and we notice something right away. Every single one of these equations has a 2 in the exponent spot, right? It's a square. Everyone has a square in it, a 2 in the exponent spot. And so if you're going to be quadratic, then your equation is always going to have a square in it. It's going to have 2 in the exponent spot. It has to. Now wonder if you see something like this. Y equals x cubed plus x squared minus 4. And you're like, wait a second, Miss Overby, is that a quadratic? Because it has a 2 in the exponent spot? Well, it's not. So we have to come back to our rule and add a little more to it. 2 in the exponent spot with no exponent than 2. Okay, so if you see 3 in the exponent spot, it's not quadratic. Now, there's a reason why we have all of these 2's in the exponent spot, and we're going to take the time to get to know quadratics much better. We have our very own quadratic unit down the road. But right now, what I want your brain to be introduced to is that quadratics look a certain way when you graph them. They look like a U, either right side up U or upside down U. And quadratic equations have a certain look in that you'll always see a square. You'll see a 2 in the exponent spot. And 2 has to be the highest exponent that you see, otherwise it's not a quadratic. I also want you to notice that you could just have y equals x squared all alone, or x squared can have company here and here. Okay? But the most important thing is we see that square. We see that power of 2. Okay, now let's look at everything absolute value. You may have seen these types of graphs. They look like V's, right? And one way you can remember it is that the word is absolute value, and the second part of the word is a V. So that's one way to remember that absolute values look like V's when you graph them. Once again, in a little bit during this semester, we will talk about why absolute values look like V's. But right now it's just an intro to say, hey, guess what? When you see a graph that looks like a V, that represents the function of an absolute value. And absolute value equations also have a certain look. We're going to see what's called, you see these 2 lines right here? These are absolute value signs. And if we were in class together, I would tell you my goofy way for remembering. I think about a football game with a referee, and when the football team scores a touchdown, what does the referee do? He or she throws their arms straight up in the air, both of them, and says, I'm absolutely sure that was a touchdown. Okay. You don't really hear them say the I'm absolutely sure part. You probably just hear touchdown. But when they're throwing their arms up, straight up, that's what they're saying. I'm absolutely sure it's a touchdown. So when you see these absolute value signs in an equation, you know that it's an absolute value equation. And so once again, we'll talk more about those absolute value signs. I know you did a little bit of work with that, with absolute values in middle school, and we'll do more investigations with them a few weeks from now. And right now, we just want to do a little intro to what exponential functions look like when you graph them and when you see their equation. So when you graph exponential functions, you see something that starts off very slowly and then shoots up. You can see it shoot up to the right, or you're going to see something that comes from the left and shoots down exponentially until it levels off. There's a reason behind why these exponential graphs look this way. And yep, you got it. Down the road this semester, we're going to do a more in-depth look into these. But right now, we just want you to be aware of what exponential graphs look like. And same thing with the exponential equations. Exponential equations always have an x in the exponent spot. Okay, so you'll always see an x up here, and you know that if you see an x in the exponent spot, it is exponential. And so we're going to do some more stuff on the back of the sheet, but I want you right now to look at the front and really compare and contrast. Maybe pause this video and compare and contrast the 4 functions as you see them on the first page. And we can always go back to everything linear and say, you know, linears are any equation that doesn't have an exponent, that doesn't have absolute value, that doesn't have, well, we could say an x in the exponent, but we already covered that. And then, of course, it doesn't have an x in the denominator. So just look at this and know that this test coming up is just going to assess whether you can recognize a graph of these 4 different functions and an equation of these 4 different functions. So let's go ahead and go to the back of the page and see what we can do. Okay, there's something here. I was hoping I had this included. You don't have this on your notes, but I'm going to need you to help me. So when I am going to take an equation like this first one and start dragging it, I want you to tell me which box to put it in. Okay, yes, I realize I can't hear you. And yes, I realize you may be listening to this tutorial and you can't like shout it out. Say it quietly or say it in your head. Ready? Where does this one go? That's right, it's absolute value. Excellent. Okay, how about this one? There's a 2 in the exponent spot. That makes it quadratic. All right, this one, there's nothing really going on. It's kind of boring. That's right, it's linear. What about this one? What do you think? Which one? Yep, I heard you. Linear. This one, it's a different form. This one's standard form, but we know this one, right? If we were to graph it, we'd use the Coverut method. That's linear. All right, there's a 2 in the exponent spot. Who is this? That's right, it's quadratic. We haven't had any exponentials yet, have we? All right, what about y equals x? Yep, that's boring. It is linear. Nothing special going on there. It's just a nice, solid linear equation. Oh, we got a 2 in the denominator. I'm sorry. We have a 2 in the exponent spot, and that's right. Anything with a 2 in the exponent spot is quadratic. All right, another one with a 2 in the exponent spot. Why, I should, oh, look at this. I have my x in the exponent spot. What is it? That's right, it's exponential. Here, I don't have an exponent, I don't have absolute values. It's pretty boring. That's right, it's linear. What about this? There's an x in the exponent spot. Nice job. Another one with an x in the exponent spot. That's right, it's exponential. And here we have absolute value signs, and that is an absolute value function. Okay, thanks for helping me with that. That was very helpful to hear you say these things. All right, so you have this one, and we've got to do a sort. So what do you guys think? The first one, I see a 2 in the exponent spot. So what do you think? That's right, that is quadratic. All right, the next one, I don't see anything. There are no exponents. There's no absolute values. So, yep, that is linear. Ooh, okay, can't go any closer to that. All right, so we had quadratic first. For A, we have linear for B. Let's look at C. I see those absolute value signs, so that means that C is absolute value. All right, D, I see an exponent, but it's a 3. Okay, if we have an exponent that's a 2, I know it's quadratic. If we have an exponent that's an x, I know it's exponential, but if we have one that's a 3, that's something else. It is a function, it's something else besides one of the ones that we've learned so far. So that's an other. And the last one, the x is an exponent spot. So it is exponential. Nice job. All right, let's see if we can get some practice in with looking at the graphs. I know that you have quads, and quads look like a U. This is a nice upside down U. You don't see the arrows, but it's implied that they're there. This is, you can write quad, you can write quadratic, you can even put a Q. All right, I see a V. Now note that this doesn't look like a complete V because we're only seeing part of the graph. But the V, this side, the left side, will continue to go up. We just don't see that part. It still is absolute value. If you want to write a V, that's fine with me. And here we've got something that's going slowly and then starts shooting up exponentially. And we know this is exponential. All right, this is another instance of exponential, except for it's dropping exponentially. Look how fast that's dropping. And then it levels off. That's also exponential. Okay, here we've got an upside down V. My V's are always going to be, that's right, absolute value. Here, once again, we're going slow, and then whoop, we shoot up exponentially. That is exponential. You have quads, and quads look like a U. So you can write quads, you can write quadratic, you can write, oops, quadratic, you can write a Q. Now, I know some people are going to think that this laying down U is a quadratic, but we have to stop and we have to remember we're looking at 4 different functions. Do you guys remember the test to see if a graph is a function? Remember that vertical line test that we said, right? If you pass a vertical line through your graph, if you move it, let's see if I can move it. Come back. Beep, 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 beep. Okay, I left my arrows behind. But, right, we're seeing beep beeps. This is not a function. So it can't, if it's not a function, it cannot be a quadratic, okay? All right, so we're going to get rid of that. Okay, so this is not a quadratic. It is actually other because it's not a function. All right, so that was fun. And what I want you to do before you go to the next thing, which I believe I have some practice for you and some sorting activities for you to do. But before you go on to that, I want you to stop and reflect. I want you to write down what ways are you going to remember how to identify what the graphs of these 4 different functions look like and what the equations look like. Because maybe my goofy methods won't work for you. You write down how you're going to remember them. Take a second, reflect, and then go ahead and move on to the activities. All right, thanks for joining me.